All right, class, welcome back. We're going to talk about how to graph quadratic functions in this section. This is section 8.5, and specifically we're going to talk about graphing quadratic functions that are in the form where the function is equal to a multiplied by x minus h squared plus k. What we're going to do is we're going to talk about what each one of these variables here, what they do. So we know the f of x would just be y, and x will just be x. But what about k? Well, what does k do? Well, if we look at just the regular graph of a parabola, so I've already written this all out here so you can pause the video and kind of take it all in. But if we have just a regular parabola and I plug in the value of -2 right here, then I get -2 squared. That's going to give me 4. So I've done the whole t-table here and then plotted those points, and you can see what this looks like, what this parabola looks like. You can also note that it is symmetric about this y-axis, meaning that if you folded it, it would be exactly the same side to side. So the axis of symmetry here, the axis of symmetry on a regular parabola is going to be that x is equal to 0. Again, that's a vertical line at 0. So that would be the axis of symmetry, which is the y-axis in this case. Okay, and then if you add 5 on the outside, not inside of this squared, but on the outside, so this is the value k. If you add 5, you can again see if you just add 5 to each one of these, so I plugged in the values again, then these are the values that you get, and you can visually see that what happens to this graph is it's exactly the same, but it just scoots up 5. Okay, so a positive k is going to shift the graph up by k units. Okay, again, a positive k will shift the graph up by k units. So if k is 3, it's going to shift it up 3. If k is 2, it's going to shift it up 2. If k is 556, it's going to shift it up 556. Okay, but if we have a negative k, again, on the outside of the squared term, so this is added outside of here. If we have a negative k, you can see I went ahead and plugged in all of these numbers. And again, please take time to pause and kind of look over each of these. But you can see what happened is the entire graph stays the exact same, but it just shifted down 1 by the units here. So if k is negative or has a negative coefficient, then if it's negative, it will shift it down. So if it was a -7, then it would shift the entire graph down 7. If it was -362, it would shift that graph down 362, but the shape and everything else about it would stay the same if this is the only shift that happens. So k shifts stuff up, positive, down if it's negative. All right, well now I want to look at graphs just below these. So what does h do? Well, here again I've plugged in points. So when we're at -2, we're at 9 here, -1, 4. So what is this -1 actually doing? Well, you can see that it's the exact same graph here, but just shifted over 1. But in this case, it shifted right, and it shifted a right one, when you would expect it to shift left. But because this is negative right here, it does the opposite of what you would expect, okay? So in this case, h itself is 1, and that's what it's doing, is it's shifting it 1, because the negative sign says it does the opposite. So I'm going to shift this graph to the right. So if the coefficient is negative or if the h is negative, then I'm literally just taking the h value and say, oh my gosh, that's a +1 right here. h's value is +1, so it's going to shift it to the right. 1. If this was x minus 7, then you would shift it to the right 7. If it was x minus 3, you would shift it to the right 3. Okay, so that is what a shift, a negative, when this is negative, that's what a shift looks like. But what about when it's positive? Well, again, I've gone ahead and plugged in all of these values here so you can look at them. And what you can see is that the graph shifts to the left. Well, why is it shifting to the left? Because this means the opposite, or it's in the form of x minus h, then we have to look and say, well, if I wanted to put it in the form of x minus h, then what would the value of h be? Well, in this case, it has to be a -2, because the opposite of a -2 is +2, and that's why this is a positive sign here. So again, a lot of people really can get hung up here on these shifts, but if you remember, K is positive, so it does what you would think. Positive up, negative down. But H is the opposite of what you think. So here, it's going to shift right, and here, it's going to shift left. Okay, so if I had x plus 9, then it would shift it left 9 units. All right, so that is what H does. Well, what does A do? Well, let's check out this graph over here. One thing that we need to know and remember is that if A is positive, then the graph is going to open upward and look like our regular parabola. Well, what about if it's negative? Well, all that does is make every one of these values negative, which flips this graph upside down. Okay, again, so you can see if there's only a vertical shift, okay, then the axis of symmetry for all of these top graphs is going to be x equals 1. The axis of symmetry is this line right here, the y-axis and the y-axis. Where is the axis of symmetry, though, on these that are shifting? Well, if I made a line where this would be, then this line would be at x equals 1. So the axis of symmetry here would be x equals 1, and the axis of symmetry here would be x equals negative 2. You can see, like, if I put a line right here at negative 2, so again, this would be x equals negative 2 would be our axis of symmetry. And we could identify all of these vertexes as well. The vertex is going to be the h value and the k value. So when we talk about vertex, the vertex is going to be whatever h is and whatever k is. So vertex here, there is no h and there is no k. So the vertex of this graph is 0, 0. That is where we started from. If I'm looking at this graph, there's no h, but there's a k. So if h is 0 and k is 5, so the vertex of this graph is at the point 0, 5. So you can see that here. And if we're looking at this graph here, you can see that there is no h, so h is 0, but y is negative 1. So we have an h of 0 and a y of negative 1. So this would be our vertex for this graph, would be 0, negative 1. Well, what about here? What's our vertex here? Well, we have an h value. The h value is 1. Let me write this in red. The h value is 1, so our vertex here is going to be 1, but there is no k out here, right? There's nothing right there, so that is just going to be 0. And you can literally see that this is the point 1, 0. The vertex is right here. And again, at this next one, there is no vertical shift. There's only horizontal shift of a negative 2. So I'm going to have negative 2. And again, this is negative because to make this be a negative right here, then this must be a negative 2. The value of h is negative. So I've got negative 2, and there is no shift vertically, so this is just going to be 0. So my vertex here is at negative 2, 0, and you can see that. Again, axis of symmetry will be at whatever the x value is of the vertex. So the x value is negative 2 here of the vertex, so the axis of symmetry is also there. All right, so what about this one? Well, its axis of symmetry is also y equals 0, which is the y-axis. But again, a negative is going to make that open downward. But shifts are going to be all the same. If I all of a sudden said, well, what about a plus 5 here? Well, this shift is on the outside, so it would still open downward, but we just shifted up 5. Okay, and if we said, oh, instead of looking like this, it was a minus 4 like this squared, well, that would just shift it to the right 5. Okay, so we could do a lot of alterations here, but no matter what, if this is negative, it's going to open downward. Okay, so you need to know that the vertex is the point hk, and remember that h is always the value of h is h when this sign is negative. Okay, so that is our shifting up and down. There's one more thing I want to talk about, and what happens if a is bigger than 1 or a is less than 1. So I'm going to erase these middle ones here, which is sad because those were beautiful. Just want to make sure I'm still recording. Okay, so I'm going to erase these middle ones, and let's see what happens if we change the value of a. So let's just say that this function here, we'll make a table for it too, just so you can see what's happening. Let's say that the function that I want to graph has a positive 4 as the a value. If I plug in negative 2, negative 2 squared is 4 times 4 is 16. So I get 16 out of here. Holy cow. Okay, negative 1, I'm going to get negative 1 squared, which is 1 times 4, which is 4. 0, I'm going to get 0 squared, which is 0 times 4, which is also 0. You can hardly tell what I wrote there. When I get 1, it's going to be 1 squared, which is 1, times 4, which is 4. And when I do 2, I get 2 squared, which is 4, times 4, which is 16. Okay, well, let's see, compared to this parabola, what happened here. Okay, so my x points are going to stay the same, but these are going to be like okay, and they're going to keep going forever. And at negative 2, I'm going to be like all the way up here, like 16. And at negative 1, I'm going to be at 1, 2, 3, 4. And then I'm going to be at 0, 0, 1, 4, and then like 2, 16 again, like all the way up here somewhere, right? So this graph then is going to look like this. Well, compared to this one over here, which has these points on it, you can see that what this did, okay, this is our regular parabola right here. What this did is it stretched it, it made it skinnier, and it stretched it by a factor of 4. So this vertically stretches this a coefficient. So if it's positive, it opens upward. If it's negative, it opens downward. But it also can vertically stretch it. And in this case, it's going to vertically stretch by a factor of 4. Well, what does that mean? Well, when I would have gone up 1 over 1 here, and up 1 over 1, because it's symmetric, I really went up 1, 2, 3, 4, and over 1. So you can see here that is the difference. It stretched it by a factor of 4. Instead of being 1, it was 4. Okay, so it's going to vertically stretch it. So if a is greater than 1, then it's going to vertically stretch it. All right, well, what happens if a is a fraction? If we had x is equal to the f of x, we want to do the f of x is equal to, let's say, 1/3 x squared. All right, so let's plug in all the same values so we can see the behavior. If I plug in negative 2 squared is 4, and 4 times 3 is 4/3. Okay, if I plug in negative 1, that's going to be 1 times 1 is 1/3. If I plug in 0, that is going to give me 0. Let me give a little more room here. If I plug in 1, that is going to give us a 1/3. And again, if I plug in 2, that is going to give us 2 squared, which is 4 times 1/3. 2 squared is 4 times 1/3 is 4/3. Okay, so what happened to this graph? Well, I'm going to go through the point 0, 0. I got negative 1 and 1/3. So let's write these here. So negative 1 and 1/3, that's going to be like right here. We've got 1 and 1/3, that's going to be right here. Negative 2 and 4/3 is going to be just barely above this whole number 1. So a third above it, and a third above it over here. So this then looks like this. When our regular parabola would look like this, up 1 over 1 and 2 to 4. So this is what the regular parabola would look like, right? The one right here, this red one here too. Okay, so this is our regular parabola, but you can see that when we have a fraction here, this vertically compressed this graph. Okay, it vertically compressed it. So instead of going up 1 and over 1, which is where these points typically are, up 1 over 1, instead we just went up 1/3 and over 1, which is a big deal. So what this did is it vertically stretched it, or sorry, vertically compressed it. So this is vertical compression. Compressed it. So it makes it, here to the stretch, you can think it makes it skinnier, longer. Skinny. Here, it's going to make it wider. That is when A is still positive, so it's greater than 0, but it's less than 1. So if this A value is between 0 and 1, so if it's any kind of a fraction or a decimal, if it's 0.3 or it's 0.9 or it is 5/3 or sorry 3/5 or whatever, if it's between 0 and 1, then this is going to make the parabola wider. But again, that axis of symmetry is still at the y-axis, whether it's skinnier or whether it is wider. Okay, and then if I had this negative, what this would do is still be the exact same thing except for flip it upside down. So if this instead said a negative 1/3, then it would flip it to upside down, right? And it would look like same thing we just did, but upside down. That's what this negative right here would do. And same thing with this 4, it would flip it upside down and it would be this super skinny upside down if that were negative. All right, so we know what K does. Positive moves it up, negative moves it down. We know that H moves the opposite. If it says X minus 2, then I'm going to move to the right 2. If it says X plus 5, then I'm going to move to the left 5. And A determines whether it opens upward or downward. Upward if it's positive, downward if it's negative. And if the coefficient is greater than 1, then it's going to stretch it out. And if it's between 0 and 1, it's going to compress that graph. So that is everything you need to know about how to graph these functions. But you also need to know how to put all of these shifts together. So I want to just do one more problem where we have multiple things happening and have you see how to graph that. So I'm going to leave this regular parabola here just so we can make a comparison. All right, so if we said, well, let's graph the function -3 x plus 5 squared minus 2. Well, we know what we need to do is we need to figure out several things. First of all, we need to figure out what is the vertex of this parabola. Well, the vertex, or the x value, is going to be whatever you would plug in right here to make this 0. But really it's the opposite. So the opposite here is -5. Okay, and then this is -2. So this is going to shift down 2. So we're going to go left 5, down 2. Okay, we know that this negative right here is going to open downward. So it's going to open downward because of the negative. And we know also that this 3 right here is going to vertically stretch this graph. Well, how much is it going to stretch it? It's going to stretch it by a factor of 3. Okay, so what does the graph look like? Oh, let me draw a different one. We want to do -5, -2, so we'll draw the line like this. All right, so all right, so again, our vertex is going to be at -5 is the x value, because this is going to shift it the opposite. This seems like it would go right, but it's going to go left, 1, 2, 3, 4, 5, and it's going to go down 2, so that's going to be right here. We know that this is going to open downward, and typically to go to the next point, we would go down 1 and right 1, and these would be the next points in this parabola. But because it's going to stretch here by this factor of 3, instead of going down 1 and right and left 1, we're going to continue down this axis of symmetry, but we're going to go down 1, 2, 1, 2, 3. And then we'll go symmetrically here. So my next points will be these 2 points right here, which if I needed to label them would be -6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. Okay, so this would be -6, 5, and this point here would be a -4, 5. And again, this parabola then is stretched from the original form, which would have been down 1 over 1. So here's how all of that works all together. You'll have to graph several of these, and I would expect to see this on the final with all the different types of shifts that could happen.